Now we're going to look at the result that we got here. Remember that I was very careful to tell you that this guy was our quotient. Let's just put a little q next to that. And this guy is our remainder. It's with the quotient that we can determine what's called the slant asymptote. This is a line that out in the extremities of the graph, the function will not cross. Now it might cross it there close to the origin towards the center of the graph, but it won't cross it later on. And so what I'm going to do, we also have vertical asymptotes. The slant asymptote comes from the quotient. The vertical asymptotes they come from the remainder. Remember how I was able to write this thing here becomes x minus 3 plus 6x minus 17 over x squared minus 4. This guy will give me my vertical asymptotes. This will give me my horizontal or slant asymptotes. In this case, x minus 3 is this line right here. I'll do a dotted line. Slope of 1, negative 3 is the y-intercept. So I'm going to do just a dotted line going through that point, goes through that point. That is my slant asymptote. My graph will not cross this line out this way or out this way. More on that later, but I'm also going to now determine my vertical asymptotes. Those are done basically wherever this denominator, remember it's a denominator, wherever it's equal to 0, my graph is going to fall apart. I can't divide by 0. Well, that happens when x is equal to negative 2 or 2. We know that negative 2 squared is 4, 4 minus 4 is 0. 2 squared is 4, 4 minus 4 is 0. If you're still lost on that, remember that this factors to x minus 2 times x plus 2, and those will show us our zeros. So at minus 2 and plus 2, I have these vertical asymptotes. The graph is definitely not going to cross these guys anywhere, because that would mean that x equals 2 is a solution. It's not. X equals minus 2. That's not a solution. Keep this in mind for the next video. But we have 2 slant asymptotes and this here. We're going to use this information and what we know from points that we have. You know, maybe we know some places where this crosses the x-axis. Maybe we can find some points. I don't think we can. I made this problem up. But we can also know what happens when x is 0. Well, when x is 0, the graph is minus 5. So that point there is something that we know on the graph. More to come next time.